Kestra is an open-source declarative data orchestrator focused on simplicity and fast development cycles. This video will walk you through key concepts in Kestra. We'll start with a Hello World flow, and we'll gradually introduce new concepts, including environment separation using namespaces, tasks, parametrization, and scheduling. Let's start by conceptually building our Hello World example. Here is a flow that logs a Hello World message to the console. The workflow is defined in a simple YAML configuration file. Each workflow consists of three required components: ID, namespace, and tasks. The workflow definition starts with ID that represents the name of the flow. Then you define a namespace. Namespace can be used to separate development and production environments. The ID of the flow must be unique within a namespace. You cannot have two flows with ID hello in the development namespace, but you can have a flow hello in the development and production namespaces at the same time. You can think of a namespace as a folder for your flows. Similarly to folders on your file system, namespaces can be used to organize flows into logical categories. And as file systems, namespaces can be indefinitely nested. Using the dot symbol, you can add hierarchical structure to your flow organization. This allows to separate not only environments, but also projects, teams, and departments. Your product, marketing, and finance teams can have their own namespaces that belong to a parent namespace, indicating the development or production environment. We've covered the flow ID and namespace. The last key component are tasks. Tasks are atomic actions in your workflow. They can be small, for example, extracting data from an API, or they can be large data processing jobs running heavy data transformations. Tasks are defined in form of a list. By default, all tasks in the list will be executed sequentially, one after the other. So the second task will start as soon as the first one finishes successfully. Kestra provides additional customization, allowing to run tasks in parallel or to allow failure of specific tasks. Check the developer guide for more details. Most tasks in Kestra are available as plugins, but many types of tasks are available in the core library, including tasks to send or fetch logs, trigger custom bash commands, or execute various Python scripts in isolated processes or Docker containers. Here you can see a simple example executing the following sequence of tasks. First, log a message to the terminal, then trigger two bash commands. Finally, execute a Python script. Apart from that, there is a wide range of additional integrations allowing you to execute Node.js scripts, invoke dbt core and dbt cloud jobs, trigger data ingestion syncs with Airbyte or Fivetran, run custom jobs on Google Vertex AI, and many more. Check the plugins documentation for a list of supported integrations. Let's now get back to the Hello World flow. Now that you know how to configure ID, namespace, and tasks, let's look at how you can parametrize that flow with runtime-specific inputs. Here is an example passing username to the Hello World message. Similarly to tasks, inputs is a list of dictionaries. Each item in this list corresponds to one input parameter. Each of those parameters is strongly typed. Here, the input with name user is of type string. There are many supported data types, including integer, boolean, float, datetime, and more. Each input can be either required or optional. If required is set to false, it's encouraged to set default values. Here, the default value for a user is prompt engineer. Finally, let's look at how you can add a schedule to your flow. Kestra is event-driven. This means that schedule is one type of external events that can trigger a flow execution. Here is a simple cron schedule that will run the flow every minute. If you need more help configuring a cron schedule, here is a cron cheat sheet. You can also ask ChatGPT to help you configure the cron expression. And you can use the cron tab guru to validate how your cron expression is working. Now that we covered all key concepts, we are ready for a hands-on demo. We'll first log into Kestra. We'll then write and run our first workflow, After the first workflow execution, we'll parameterize that flow with custom, strongly typed inputs. Then we'll iterate on that flow by adding a Bash and Python scripts, using the code editor integrated within the UI. Finally, we'll schedule that flow to ensure it runs on a regular cadence. This is the login screen of a production instance. When I log in, I can see the home screen. And here's the UI when you start the default open source version. If you navigate to Settings, you can configure the theme, your default log level, and a default namespace. Let's navigate to Flows. Let's create a new flow from scratch. The welcome screen provides a step-by-step tour to explain the key workflow components. Let's skip that tour and create a new workflow entirely from scratch. Copy and paste the Hello World example code and save it. While building your flow directly within the UI, you gain the Autocompletion feature. Let's demonstrate that by adding a Bash task. One useful feature is the embedded plugins documentation built directly within the UI. We can view examples, and we can see exact properties of the plugin. Let's save that flow. Now that we added a new task, you may notice that the version of the flow changed. You can see the modifications and the new version number. In the enterprise version, you can additionally see who made specific change and when. Let's switch back. You can easily restore a previous version. Also, from the topology view, you can see the task composition. This is the directed acyclic graph of your workflow. You can switch the view from left to right to top to bottom. The same topology view is available within the editor. So here we can switch between topology, source and topology, source and documentation, or just the source code. Let's now run this workflow. On this flow execution page, there are several tabs. The Gantt view displays the task execution against time, showing the start time, the end time, and the duration of each task run. The overview displays execution metadata, including the inputs the flow was triggered with. Logs show all execution logs grouped by the tasks. You can see the task name, the logo, the execution attempt, the log level, the duration, and the final state. You can change the log level to trace to get even more information, and you can do a full text search on your logs. The topology view shows the dependency graph of your tasks as they got executed. Outputs allow you to view output artifacts of any given task, and if your task returns a file, you can even download it from here. Finally, metrics allow you to track additional metadata that might be useful if you want to track metrics such as the number of rows processed in each partition and the processing time. Let's modify the flow again. Save it. The revision changed again, and now let's trigger that workflow with a different input parameter. You can think of a parameterized workflow as a function that can be defined once and executed many times, each time using different input arguments. Finally, let's add a schedule to that flow. Again, you can see the documentation with examples how you can configure the cron expression, how you can set up backfills. Save it. Now we need to wait a minute to see the first scheduled workflow being triggered. You will notice that flows triggered manually have no trigger. You can see here the trigger is empty. Otherwise, the trigger type will be visible here in the UI. The trigger type is indicated by the first letter. S means schedule, F means flow trigger, and W means webhook trigger. Let's get back to the UI. And now we can see that schedule is working. and the variables metadata showing schedule date, schedule next, and schedule previous confirms that the workflow has been triggered on schedule. Let's now add a Python task to the flow. Here's the documentation and examples, explanation of properties of a Python task. Let's save it, and let's run it. In the logs, we should soon see "Hello from Python." That's all for this demo. Thank you for watching, and see you next time.